Welcome to Revised Chemistry with Mr. B. In this video, we're going to measure the rate of reaction during a chemical reaction. And we're trying to find out, do chemical reactions start off slow and then speed up? Do they start off fast and then slow down? Or do they go the same speed throughout the reaction? One way of measuring the rate of reaction if a gas is produced is to use a gas syringe. So I've got a conical flask connected to the gas syringe, and in the flask I've already got some magnesium. I'm going to add to it 50 centimeters cubed of hydrochloric acid, and as soon as that's in, I'm going to make sure I start the stopwatch, and then every 10 seconds I would read the new volume of gas on the gas syringe. The results you get would look something like this. So here I've marked 3 tangents on the graph. And what does the graph actually tell us? Well, things to notice are the gradient at 10 seconds is steeper than the gradient at 50 seconds. And the line has leveled off once we get to 80 seconds. So that tells us from the steep gradient at 10 seconds that the reaction is going fast at 10 seconds, or there's a high rate of reaction. Because the gradient's not as steep at 50 seconds, that tells us the reaction is slowing down, or a lower rate of reaction. And where it's leveled off, that tells us the reaction has now stopped. Now, if we wanted to know how much the rate is slowing down as the reaction goes on and put a number on it and be quantitative, well, to do that, we'd have to find the rate of reaction at the specific times by calculating the gradient of the graph. And I'll put a link up here now to a previous video that shows you how to do that. This is another method we could use to measure the rate of reaction during a reaction. So I've got some calcium carbonate pieces in there, and I'm going to add some hydrochloric acid to it, and we should start to see some bubbling and fizzing because the gas will be given off. So the contents of the flask will start to get gradually lighter as the gas is given off. So we would measure the mass of the flask and its contents every 10 seconds or every 30 seconds. You'll also notice I've got some cotton wool in the neck of the conical flask. That's to make sure any acid doesn't spray out of the top of there, but at the same time it's letting that carbon dioxide gas out that's being produced so that the mass will therefore change. This time the results would look something like this. So the graph is downward sloping because the mass is decreasing as the gas is being given off. And if we draw a tangent at the start, we can see the gradient is still high, which suggests a fast reaction or high rate of reaction. Partway through, the tangent is not as steep a gradient, and that shows that the reaction is slowing down or a lower rate of reaction. And then finally, the tangent is level, so that tells us that the reaction has stopped. So once again, we can see that the reaction starts off fast and then slows down and then finally stops. What we've seen during this reaction can be explained by collision theory, and this is a theory that we keep returning to for the rest of the topic. And this theory states that for a chemical reaction to happen, the reactant particles must collide with each other, and also the particles must have enough energy for them to react. And the minimum amount of energy that particles need when they collide in order to react is called the activation energy. If the particles do have enough energy when they collide, so if they have got the activation energy, then they will cause a reaction. This is known as a successful collision. So why do chemical reactions start off fast, then slow down and finally stop? Well, at the start we can see there are lots of reactant particles, so when the chemicals have just been mixed together, there will be a high frequency of collisions and a high rate of reaction. Partway through the reaction, we can see that some of the particles have been used up, so there are less reactant particles left. There will be less frequent collisions and a lower rate of reaction. And eventually, there will be no more particles for one of the reactants, so this is why the reaction finishes. In the next video, we're going to start looking at the factors that can affect the rate of reaction, either causing the reaction to speed up or slow down. So to see that video, simply click the on-screen link now. Thank you for watching.